Welcome to DESI ASTRO. In this Python tutorial on Astropy, our objective is to learn that how to mask a fixed astronomical spectra, in which we will be learning that how to mask spectral regions in certain wavelength and how to mask emission and absorption lines in that spectra. So masking astronomical spectra is the process in which we selectively ignore or exclude certain regions of the wavelength or emission or absorption lines in that spectra. So this is usually used to eliminate unwanted features such as skylines or any artifacts which can be lead to the inaccurate result and interpretation of the data. So this region could be affected by various factors will be discussed later. So first understand from this sample spectra, you can see that here I have a spectra. On x-axis I have a wavelength, on y-axis there is a flux unit. Okay, so here you can see that my blue spectra is the original spectra and it is going all over the wavelength range. Okay, and then I have this orange spectra on the either side of the original spectra and which has been masked. Okay, so it means that in our analysis only this blue spectra will be included and rest will be excluded, right? So for that it means that the orange color region is not going to include in our spectral analysis and other measurement. Okay, so now I will discuss various factors which can affect these spectral regions. Okay, so I have pointed out some 4 or 5 regions. Okay, so here you can see that I have some telluric lines which is caused by the molecules present in the Earth's atmosphere, and then the cosmic ray which are high energy particles which can hit your spectrograph and it can produce some spikes, right? And then there can be some instrumental defects and artifacts such as bad pixels and which can create noise in at certain wavelength points. Okay, and then there can be some skylines which is caused by air glow or light pollutions in the atmosphere, and also suppose you want to exclude certain emission or absorption lines so which are not of your interest, so sometimes you need to mask them to simplify your analysis and deriving properties from the spectra. So there are some causes which usually happens, and then we'll go to before proceeding further, you must have a fixed spectra in your directory. Okay, so here I'm not going to show you that how to download the fixed spectra, and for downloading the fixed spectra you can watch this video given on the screen, and I have also attached the link in the video description, right? I will start the actual coding with Python. Okay, so first of all I will import some libraries. So import library. So I will import Astropy. So from Astropy dot input output import feeds, right? So this deals with your feeds file, right? Feeds file handling and then I can import a numpy. So this takes care of your number Python and arrays, right? Then I can import matplotlib. So import matplotlib.pyplot as plt. So this deals with data plotting and visualization. Okay, so these three libraries we need to import at least, and then here I will open my feeds file, right? So for that you can type here Spectra equal to feeds.open function, right? And you can give here your file name. Okay, so in my case I have this Spectra, right? And then you can extract information about your feeds file, right? So for that type here Spectra dot info and give your function, right? And run it. So here you can see that you have your primary SDU, query and object, right? So here you can see that your the first SDU contains your binary table SDU, and it has this much of row and 8 columns. Okay, so our Spectra is in the first SDU, right? So for that go to your go to your one or code SDU, right? And then you can extract data. Okay, so just first go, so you can go here, say data equal to your Spectra, right? Spectra, or given a square bracket. So either you can write 1, okay, or you can write the string, that, and you can write dot data, right? So if you type here data, you can see there is a flux, right? We have log lambda, so wavelength on the log scale. You have inverse variance and mask and model. Okay, so I have to extract, or maybe you can do one more thing, you can go for the header. Okay, so you just do here extract header information of first SDU, right? So you can type here SDR equal to Spectra dot give attribute as a header, right? And then you can print your SDR. So you can see you have this much of your flux. Okay, you have data to log. First extract your wavelength or lambda, right? So just call it your wavelength equal to go to your data. Okay, so data and give a square bracket, and then extract your keyword call a log lambda. Okay, so just copy this keyword and give it as a string, right? And you can, so this is the log scale, so you can make it linear scale. So make it this 10^2, then you can print your wavelength. This is where wavelength axis is there. Okay, and then you can extract your flux. Okay, so extract flux. In the same way, type here flux equal to your data, right? And then give this keyword flux. Okay, so flux, and you can print your flux, right? So this is your flux. Okay, now we will be doing a simple spectra plotting. So plot this full spectra, right? So you can type here plt.figure, right? And then you can type here plt.plot, and then you can pass your x-axis and then your y-axis, and you can give a label, say a spectra, or just call it original spectra, right? Original spectra, right? And you can type here plt.legend, and you can also do plt.show for plotting. Okay, so here you can see that I have a simple spectra, right? So this goes from around 3800 to around 9500 angstrom, right? So you can also give a title to this simply plt.x level. X level you can give, say, wavelength, right? And you can give y level as a flux, right? So y level as a flux, right? So simple spectra. Now we have done this much. So what we will be doing will be so for that, first of all, we need to define a masked region on wavelength axis, right? So for that you can create a variable here, say mask region, right? Mask region equal to, give a bracket here, and you want to take your wavelength, say greater than 6000 on x-axis, and you want to go for wavelength less than, say, 7000, right? So now if you print here mask region, so if you print here mask region, let's see what it is printing. Mask region, so false. Okay, this means it has been created a masked array of wavelength, right? So only in that region this is being true, else it will be false. Okay, now mask the flux corresponding for masking the flux, you need to type here a function called np.where, so it will mask the y value corresponding to your x value. Okay, so np.where, and you can give your, say, mask region, right? Mask region, and then you can give your, say, flux you want to mask, and you want to replace your that y value with something. So I want to replace this value with np.not a number. Okay, so if you print here masked flux, let's see what it is running. You can see there is not a number value. Okay, right? So it means that in this region there is no flux, right? So let's do it. So for that, now plot a spectra, right? Now plot a masked spectra. So for that, type here command plt dot plot, and you can give here a wavelength, right? And then you can give here your masked flux, right? And then you can give a label, just call it masked spectra, right? Now run it. So what is the mistake here? So there should be L. Now fine. So here is my result. So here you can see that blue one is my original spectra, right? And the orange one is your masked spectra, right? So from 6000 to 7000 on x-axis your spectra has been masked. Okay, there should be this way you can mask your spectra, and you can play with this your masking, right? So suppose I want to go to 2000 to 7000, right? So you can see your much bigger spectra, the portion has been masked. Okay, all right, and you can also do some mode adjustment, right? So let's go to 5000, right? So this is my masked spectra, right? You can also like mask a certain spectral lines. Okay, yeah. So just you like give the range of your spectra, right? So it will mask that spectra. I hope now we'll be able to mask any spectra using this Python code. So let's revise this code once again. So for that I have imported some libraries such as NumPy, Matplotlib and Fits. Then I have simply opened our Fits file using Astropy. Then I have extracted the spectral information about the Fits data, and then I have extracted our data from your binary table SDU, and in which I have flux and wavelength on the log scale, right? After that I have extracted your wavelength and flux, okay, using this attribute, and then I have plotted this spectra, the full spectra. Then I have defined a mask region on the x-axis, and then I have given corresponding mask on the y-axis, and then I have finally plotted this mask spectra, right? So this is the final product, in which you can see I have original spectra and I have the masked spectra. So I hope you got the full idea. So thank you, and stay tuned for the next video.